I'm going to introduce our next speaker, Kanika Sharma, and she is representing Norway. We are very excited to have you here. Kanika is a data scientist at Siemens. She has a very extensive, broad, an interesting background within the field, and she's going to talk to us about employee happiness. So go ahead, Kanika. It seems Kanika is not in the stream. Kanika, can you try to reload the page and then join again? Hello. Can you hear me? No? The technology ghost has appeared again. It's the inevitable technology ghost. So, okay, if you click settings at the bottom, the little cogwheel, can you, you could hear me before the lunch break. 1 second. You are also muted. If you click the cogwheel, you'll be able to see different options, which sound source you're using. Maybe you're using the wrong sound source. I'm talking and she's not hearing me. I'm sorry. I'm gonna write to her. You can hear me? Yeah, and if you unmute. And you can still hear me? Yes. Is your unmute button unmuted? We can't hear you. So are you unmuted on your end? Yes or no? You are, okay. So we are having some issues with that. We did test this, so I'm not entirely sure. Let me just check with our backend here what we can do. Are you on a work computer? Is it the same computer you used in the tech test? Okay, give us 1 second. Yeah, we are really sorry about this. We tested it and apparently it doesn't work. You could try another browser. Use the same link and try another browser if you can do that.
Can you hear me now?
Yes.
Okay.
All right.
I think it was probably some browser permissions and controls. Yeah.
All right, but that's okay. Take your time. We will go a little bit over time, so we're not eating on your time. So, okay, Kanika, great. Go ahead.
Yep. Thank you so much, Lena, for introducing me. And I will be sharing my screen now. I hope you guys can see my screen now. So the topic that I'm presenting is employee progression analysis and strategies for reducing churn with an example of an end-to-end data pipeline. So in this presentation, we'll be going through a use case, requirements gathering, strategy, solution, different layers, and finally an outcome. But before proceeding further, a little bit about me. I'm Kanika Sharma, and I'm a data scientist at Siemens Mobility Norway, and I work for digitalization and cybersecurity team. And we aim to provide innovative services and digital transformation to our customers in railway sector using our internal
Hi,
platform
Kanika.
like Religent and
Sorry
Accelerator.
for
And
interrupting you.
we aim to improve the punctuality in the railway sector.
Sorry, can you hear me, Kanika?
Yeah.
Sorry, Kanika?
Yeah.
Okay, can we just ask you to please make the presentation full screen?
Sorry.
Thank you very much. Please continue.
Yeah. Okay. So the use case that I'm presenting today is a project that I worked on in my and one of our customers wanted to see the entire employee career journey from the onboarding to the exit, and also kind of like how the employee has been growing within the organization. So the customer was interested in understanding how the employee is performing and how they are receiving, if they are receiving the right support and the guidance to move ahead and achieve their career goals. And they were also interested in seeing if their internal learning tool is offering the relevant resources and recommending the relevant resources and the learning material that they need to go and achieve their goals. And if it was providing the useful statistics across the organization that they need for their decision making. And they were also interested in looking into the exit interviews to find out why employees leave the organization and how they can improve it by the feedback. Yeah. So for this use case, what we did was we started with the requirements gathering, and it's not just the phase where we do a documentation of the requirements, but we actually it's more of a process. So you need to understand as a solution architect or a data architect that what are the different verticals and the horizontal levels within the organization. You need to interview the managers or the management people wearing those hats responsible for those verticals and the horizontals. You need to understand management's perspective in the employee's career journey and how they are supporting the employees working under them. And you need to understand how the internal platform is providing the statistics for them to make these decision makings and how closely it is aligned with the employee's career path or the development path. And lastly, you need to gather the exit interviews and the survey data from the human resources if it's suitable enough to be shared publicly. So from this requirement gathering phase, we moved on to our strategy. But how do you form a strategy? So you think of those requirements that you collected in the previous phase, and then you start with these steps. Summarize. You summarize the interviews and establish the business objectives. B, define the key performance indicators. So you need to look into the KPIs that the business is interested into. What is the definition of it? What is the meaning of that KPI? C, map those KPIs to the business objectives that you gathered from the interviews. D, connect with the data team. Now, this is also very important because you need to find out how to get that data. Where is that data hiding, and how can I fetch that data? And if it's feasible enough or not. E, consider governance, security, and timeline. So this is of utmost importance and highly unspoken and hidden. We will talk about a little bit more on the governance and security in the later slides. But to give you an idea, this is more about GDPR compliance, privacy laws. And for the timeline, what I would like to add here is that often we talk about getting the data, but we do not realize if we will be able to get enough and reliable data within the project timeline. So this is really important to include this point within the strategy phase, that if you will be able to get enough data within the whole timeline that you have set up for the project. And lastly, identify a centralized and scalable platform and deliver it to the customer through any service, intuitive dashboard, mobile app, or any other platform that they are more suited with. So once you have formed the strategy, how do you go ahead? You try to find out a solution that suits best and aligns best with this strategy. And that would be, for this use case, an end-to-end data pipeline. So the layout that you see in front of you is what we implemented in our project. And on the left-hand side, you see the data collection. So we collected the data from different data sources. In the middle, you see a data architecture showing 3 layers: raw layer, clean layer, and aggregated layer. So basically, the data flows through each one of these layers, improving its quality. And you might have heard about these layers with a different name in the database context, as bronze layer, silver layer, and gold layer. So, and on the right-hand side, you see the dashboard, which means that the data is finally getting shared via a dashboard or a mobile app or any other that customer would like to. So now we can go deep into each one of these layers. Raw layer, as the name suggests, we collect and store the data in its raw format or as is format. You can choose the type of ingestion that you want to do, whether it can be a full load or a historical load or incremental load. That's completely your choice. And we extract the data from any kind of data source, be it a legacy system, be it an API, Excel, which is quite common even today, XML, JSON file, cloud services, streaming data, which is trending a lot. So put it in the raw layer. And the next step is the data governance. So this is, I would say, most essential part of this layer. This means that you need to make your data compliant with the GDPR policies with respect to the region and the country the data belongs to. So to give you an example, the project that we were working on for this use case, we had to follow strict GDPR policies for the data coming from Germany, and also for Russia during the Ukraine war. So the second in this would be data masking. So that is to ensure that you hide or mask the personal data. So for this, we had users' personal data, for example, ethnicity, home address, and gender, and we masked it during the ingestion on the fly as well as when we saved it. So it means that when the data is getting extracted from the data source and it's getting landed on the raw layer, it gets masked during that process. So you do not get to see the original data, which is the purpose of this data governance. Next is data processing, which means once we have taken the data inside the raw layer, now we need to define the table, establish the table structures, and create the primary keys and implement the date formats. Now, the date formats is why we need to implement the date formats here is because dates often come into different formats in a way, DD, YY, or YY, DD, hour, minute, seconds, and even with the different time zones. So you need to have a standard time date so that in the future or in the later stages of the project, you can filter the data out when the customer says that, hey, we do not want to process the data that is more than 5-year-old or more than 10 years old. So implementing the date comes really handy in the later stages. Lastly, it's a data security, which means since we are having the data in its original format, we need to maintain the highest security and with the minimum permission. So that means avoid giving access to as many people as possible and have controlled access. Maybe one admin is enough on this layer if suited. So expected output. What we were able to achieve by the end of this layer was a full table of organization, all the tables for departments, all the tables for employees, all the dimension tables related to the employees, sort of like metadata, all the tables about learnings, what kind of learnings we have, and transactional data about the learning. So this layer is mostly done by a data engineer. It falls into the lap of a data engineer, and it's done along with the collaboration from the data or the operations team that will give you the source for the data, as well as the compliance team to implement the data governance part. Next, we have the clean layer. So this falls mostly, it's a mix, but it falls into the lap of both data scientist and a data engineer. It can be overlapping or over clashing, but it varies according to the project, and it's really difficult to define a boundary. The first thing that we do here in this layer is designing a schema. So we design a schema that is optimized and tailored to the data that we have, keeping in mind the aggregations that we have to do to achieve those KPIs that we have set in our strategy. So we extract the tables from the raw using the primary keys, and we join them together using the foreign keys. So that would mean avoid picking any unnecessary tables that you do not need in this layer. So keep it clean as much as possible. So once we are done with that step, now the data is ready to be cleaned and explored, which means removing duplicates, looking into the null values, exploring the data using charts and distribution, histograms, finding out outliers or trends. And it's why we need to do this is because it's nearly impossible for anyone to go through all the columns of the table and understand what's happening inside that data. So in order for you to find out what's hidden inside it, you need to actually explore it through the visualization. So that would help you do the feature engineering, which is nothing but making new columns that has more meaning or more understandability. So, and that would also give you a chance to handle the distributions and outliers and normalize the data. So normalization of the data basically means standardizing the data throughout the whole data set. So just the example would be is that, let's say the learning is assessed in one country as numbers like 10, 20, 30, 40. But in another country, the learning is assessed as ratings of A, B, C, D. So if you need to compare both the learnings, you need to have standard data. So that's the data normalization, and that's quite common in such kind of projects. So expected output. At the end of this layer, what we were able to achieve was a combination of all the dimension tables all together as a fact table, and the fact table for employee, fact table for learning, table for organizations, hierarchy. So to see that how the organization is divided within the whole other departments and how it's going across the employees. And lastly, now we have the aggregated layer. So what I'm trying to show in this slide is basically what we can do in the aggregated layer, as well as how we can share it with the end user. So the first thing that you do is data aggregation and curation, which means extracting the table from the clean layer and performing the aggregations to make those KPIs. So that would mean that once you have the tables from the raw, you took the tables from the raw layer and it went through the clean layer, and now and for each employee, we're talking about how many learnings each employee did. So that kind of aggregation would happen here. Machine learning implementation. this is optional and not entirely mandatory, but this is the layer where it is mostly done, because the data is clean enough and ready to be used by the machine learning models. So for our use case, we did deploy the machine learning models to recommend and suggest the learning suitable to the employee for their skill set and the domain. And we also used it to predict the likelihood of the churn. So a small example would be a gym membership. So if you know a customer who's not going to the gym for, let's say, 6 months, so you can probably predict that that customer is maybe not interested to go to the gym, or maybe do not have sufficient time. So similarly, in the same context, if the employee has not logged into the learning platform for more than 6 months or a year, there's a good chance that they are probably busy or not interested in moving, or do not have a development path within the organization. So it gives the management a chance to look deeper into such kind of scenarios. Next, we have query optimization and denormalization. So because these aggregations demand a lot of calculations, we need to optimize the queries for a better performance. And why we need to do this is because, let's say the customer would be looking into the dashboard, and another customer is looking on a mobile app, and the data is getting loaded every other minute or every other second, or it's probably getting rendered on a browser, getting loaded every night. So that would mean the query runs every day, every night, or every minute. So you need to have an optimized query, and you need to avoid any heavy columns, any unnecessary columns from this layer. So this also means that although you have defined the 3 layers in the beginning of the project, you have to go back in the previous layer and kind of do a back and forth system to define if we actually need those columns or data in this layer or not to optimize our query. Yeah. Then data beautification to adapt the KPI. Just as the name suggests, we often work with the coding guidelines, and we have those underscore in the column names. So they are not understandable by anyone. So we need to rename the column names so that anyone who is accessing the tables can understand what this column means. And lastly is BI tool integration and data security. So we need to make sure that the data is accessible and integrated with any BI tool or platform or service that the customer is mostly suited with, or they already have an integrated platform. And you need to make sure that it's accessible with the controlled access or roles and permissions. So that would mean mostly it's 1 or 2 people who have write access so that they can make changes if they need to, and then rest of the users might have read access to just understand this data or see or use it in expected output. What we were able to do by the end of this layer for our use case was to finally get a table to get aggregated statistics for each employee and for each department and for overall for the whole organization. So that way, that final aggregation helped us achieve the KPIs that we talked about during the interviews with the managers. Yeah. So lastly, we have is outcome on the dashboard. Due to the privacy reasons, I couldn't show you the dashboard that we built, but I did manage to remember the KPIs, the main KPIs that we had, and I asked ChatGPT to make me a dashboard, and it came quite close. So you can see that it has shown most courses not started, most courses completed, onboarding hours, annual employees by the training hours. So it's quite close to what we actually built. And these were the main KPIs. For example, popular courses on the learning tool, yearly comparison of the employees, onboarding versus attrition rates, completion rate versus engagement rate, comparison of the target hours and actual hours, and other examples like this. Yeah. I have added these references to add a little bit of more context to what I've presented. So anyone interested in going deeper into the data architecture can refer to this book published by O'Reilly. The book name is Building Medallion Architectures. And for the two YouTube videos, these are from one of the previous talks in the same conference, and they are on the data governance and data science as a service. Very well spoken and very well explained by Philippa and Karin. So I would request the organizers to add this link as well, so that the audience can go through these if they have the chance. Yeah. Thank you.
Thank you so much, Kanika. Very interesting. Are you ready for some questions?
Yep.
Yeah. Okay, so let's see. You mentioned that you mask the gender and other sensitive demographic data. Is it removed completely or just modified? Asking because it would be interesting data to use. It could help identify effective bias in the organization.
Well, if the use case would have been on the bias, then the question would have been, or the solution would have been different. But for our use case, the topic was about the learning tools usage and statistics. So that data was not needed at all. So that's why it was masked, and it was not modified, not removed, but just masked, which means we did have the column names, but the data was like random numbers or random text. So we never got to see the original data.
Mm. Did you do anything to attempt to leverage demographics data?
No.
No?
No, not for our use case, no.
Yeah.
That was not the idea, no.
Okay. Yeah, sorry.
I'm taking a look at the other question. How long did the whole project last?
Exactly.
What took the most time? Yeah.
What
took the most time? Yes, what took the most time was actually the raw layer, because it was a lot of discussion. Like I said in the presentation, that it's a job of a data engineer along with the data team, operations team, and the compliance team. But even the data scientists like me were also involved, because they also needed to understand what we need in the clean layer, what we need to do in the KPI aggregations. So I think a lot of discussion went by in the raw layer, and the whole project took more than 9 months or something. But yeah, even then, after that, it was still in the maintenance or the support phase.
Mm. Maybe I also thought about a point you made in the beginning, which was that you thought about the time span of the project before you started, and made sure that the data engineering bits could fit into that time frame. I think that was maybe not we don't tend to do that.
Yeah, you're right. Mm-hmm.
Yeah. All right, thank you. We're going to wrap it up, and big thank you, Kanika. This was really interesting.
Thank you so much, Lena. Yeah, and